Hello everyone. Can you all just write yes in chat if I'm audible? Am I audible? Just one second. Okay, am I audible now? Just one second. Just give me a few minutes, guys. I think there is a technical difficulty. Yeah. Hello. I think I'm audible. Yeah. So we'll start with the presentation, and this is the first presentation from Developer Student Club, and this is also first time for me that I'm live, and honestly, I'm quite nervous. All right, one virus and everything goes virtual. Yeah. So our first virtual event or training session on Git. Let me start the. Yeah. I hope it is visible. Yeah. So Git is the most fundamental tool for open source contribution, and regardless of the fact that you're a open source contributor or not, Git is still the most fundamental tool for a developer to know. And this presentation is for you all. Let's get started. All right. So, uh, first of all, we have the timeline of this presentation. First, we'll be talking a bit about intro to Git. What is Git? Why is Git? Then we'll move on to the history of the Git. And I think Git is not too old. It started in 2005, and we'll discuss a bit about that. Then we'll move on with the Git concepts. Git is confusing. We have to agree. And I think I'll try my level best to give you as clear picture as possible. Later, we'll look at open source and Google Summer of Code. We have Divyanshu Mahajan for giving a talk on GSoC. So, our first topic for today: what is Git? So, you all must know about the undo option in computer, right? So, I think the undo option is the most useful invention in computer science, and you can try imagining your life without undo option, right? So, Git is something similar, but for the developers. And on the same note, Git is much more extensive than what undo can do. So Git is a version control system. More specifically, Git is a distributed version control system. What does distributed means? So distributed means that uh, same source code can be present on multiple computers, on two or more computers at the same time, and they can be maintained by multiple owners. Git is used to track changes in source code. So if you are making any contribution to a project, you can uh, track all the changes that you have made from the beginning of the project using Git. And Git supports non-linear workflow. So what does this mean? For example, while working in a notepad, when you press Ctrl Z, there is only a single history. So you'll type A and then B. When you'll press Ctrl Z, there'll be only one history to go back to. There'll be one history to revert to, right? But Git supports non-linear workflow. There can be multiple histories, and you can move across any part of the history using Git. So a brief history about Git. So back in the days when Linux was, everyone was contributing to Linux, and it was open source software. It still is an open source software, but back in 1998, it was quite painful to maintain, contributions from hundreds of different developers. There was no system to, to allow everyone to make contributions to Linux. In 1998, BitKeeper was mentioned as the solution for this entire havoc. And there was some concern related to BitKeeper. First of all, it was a proprietary software. So basically what Linux is, it's a flagship free software, right? But due to BitKeeper being proprietary software, there was not everyone was quite happy with the decision to move forward with using BitKeeper as a source code management system for Linux. Next problem was that BitKeeper required certain meta information to be stored on the server of Bitmover, which is the company that has created BitKeeper, right? So why was this a problem? The problem was that any developer cannot work on project about which Bitmover is not aware about, and this was very difficult for small developers to work on their own projects using BitKeeper, because this was a part of the agreement while you were using BitKeeper. Another part of the agreement was that while using BitKeeper, you cannot develop a software that is either a clone or something similar to BitKeeper. You cannot work on a software that does the same thing as BitKeeper, right? So in 2005, I think in April or May in 2005, an employee of OSDL, he developed something that was a very fundamental part of what BitKeeper does. And due to that, there was a conflict between Bitmover and OSDL. And basically BitKeeper, what they decided to do was they refused to sell license to anyone employed by OSDL. And who was in OSDL? Well, as the story goes, in 2005, this guy, his name is Linus Torvalds, he created Git, and he's also the creator of Linux. So he created Git for managing the source code of Linux, and later on it was widely adopted by Linux developers. All right. Now we'll be starting with the Git concepts. We'll starting with our learning of Git. So any project that is there, if Git is enabled in the project, it is called a repository. And there are two types of repositories. One is local repository. Local repository are the projects that are present in your local machine, and it is accessed only by the owner of the local machine. Next, we have remote repository. Remote repository is basically a repository that is not present in your system. It is there somewhere on the server. And for storing remote repositories, we have websites like GitHub or GitLab. Any project on a remote repository can be public or private. Public repositories are those that can be accessed by anyone on the internet. while private repositories are those that cannot be accessed by anyone other than you or the owner of the project or the collaborators. So basically, the concept of Git is that you can maintain different versions of same source code at the same time. There can be different versions of same source code, and those are called branches of the project, of the repository. Yeah. So here is our first command for Git. This is called Git Init. What it does is it initializes any project, any folder as Git repository. So I'll just quickly demonstrate you the initialization of the Git repository. Okay. So this is our folder. This is our project folder. This is our simple project folder. There's nothing inside it except one HTML file. All right. So what do you have to do to initialize this as the Git repository? First of all, you have to download Git. You can download the Git from the official Git website. Yeah. You have to download the Git from the official website, and after downloading Git and installing Git, you'll be able to see Git bash option here on right clicking in Windows. On opening Git bash, you can type those commands which were mentioned there. Git init. Yeah. So what Git init does is it initializes the empty Git repository, and you can see there is a .git folder here created. We did not create the .git folder. It was created by Git. Yeah. So we have initialized Git. We have initialized our project as Git repository. Now it is time to make changes to the project. All right. So just one second. Yeah. This was our HTML file, right? It has a few lines of code in it. Let's wait for a few minutes. Yep. It has a few lines of code in it, and we can make changes to this project. Maybe we want to add a paragraph here saying random things, right? Yeah. So once we have done that, we might want to commit those changes. Commit is similar to saving any file on Git. Sorry, not on Git. Saving any file anywhere. All right. So we'll see how we can commit that changes. Any changes, first of all, let us talk about a few concepts. Any changes that are made on Git, those changes, those files are put in an area that is called the working area. That is one concept of Git. If you make any change to any file after committing the changes, those files are put in a working area, and to commit those file to next commit, you have to first add those files, the files in which the changes were made. You have to first add those files to the staging area, right? So how do we add the file to the staging area? Yeah. So just one second. Yeah. So let's say we had a commit. First of all, the latest commit is known as the head of the Git tree, and we might have made some changes, and now we want to make a commit to those changes. So first we'll put those files in the staging area so that we can commit those files in the next commit. All right. So the command for doing that is git add and file name. Let me just quickly demonstrate you. Yeah. So git add, and the file name is index.html. Index.html. All right. Now this file has been moved from the working area to the staging area, which means that this will be a part of the next commit when we'll enter the command for commit. So now that we have added added a file to the staging area, just one second. Yeah. Now that we have added the file to the staging area, we'll go ahead with making a commit. So we have added the file to the staging area. Now the command for making commit is git commit. All right. So what it does is it creates a next commit, and as you can see, the head moved from here to here. All right. It might be a bit confusing. I might be a little I might sound a little confusing, but just stay with me. I think you'll get something out of this presentation, right? So the command for making a commit is known as git commit. All right. So we'll commit all the changes. The complete syntax is git commit -m. After this, we'll put a message that will be saved along with the commit. For example, this time we want a message to be just random stuff. This can be anything. It does not need to be the things that you have changed, but it has to be meaningful. I mean, once you'll once you'll be working on a software, you might have to you might have to look at all the previous commits, and you might want to make something out of your commits, right? So try to keep your messages meaningful and short, right? So we have committed the changes. Yep. Next, we'll be learning about working with the remote repository. For now, we were working with the local repository only. The index.html was present on our local machine. So whatever we did, we initialized the repository, we made changes, and we created a commit. Whatever we did with the local repository. Now we'll be working with the remote repository as well. This red line represents our remote repository. So how do we create a remote repository first? So yeah, just one second. Yeah, I'll be using GitHub for demonstrating the remote repository. We'll create a new repository using this button. I think on GitLab it will be something similar. Git tutorial will give a name to our remote repository. It is already present. Okay, so git tut. All right. We have created our remote repository on our GitHub. All right. So you might be able to see there's a link here. All right. There's a link here. So you might have to connect your remote repository with your local repository. And for doing that, we have a command that is that looks similar to this. Git remote add the name of the remote repository and the link of the remote repository. We can give any name to our remote repository here. For example, mostly it will be origin. Mostly people prefer to give origin as the name for the remote repository. So we'll connect our local repository with the remote repository so that we can push everything that we have in the local machine to the remote repository. For doing that, this is the command: git remote add origin, and the next thing was the link. All right. So for the link, you just have to copy this, open the git bash, and for pasting you have to press shift and insert shift plus insert, that will paste the link. Now we have added the remote repository in our local repository, and we have given the name origin to the remote repository. Whenever we'll be referring to the remote repository, we'll be using the name origin. Okay. Now we have to okay, just give me a few minutes. I'm sorry for this. Okay, sorry, I think I was not. Sorry, I'm sorry. I think I was not audible for past few minutes. Sorry. I'll just repeat everything that. Sorry. Yeah, I'll just repeat everything that I just said. Yeah. So after we have connected our local repository, after we have connected our remote repository to our local repository, we can push everything that we have in the local repository to the remote repository. And for doing that, we have command git push origin branch. Origin is actually the name of the remote repository that we gave earlier to our remote repository, right? So for the demonstration purposes, you can see that when I execute this command, earlier the remote repository was not even with the local repository, and as soon as I execute this command, everything gets pushed to the to the remote repository, and both of the repositories get even with each other, right? So I'll just quickly demonstrate you how to push all your everything in your local repository to your remote repository. Git push origin master is the branch name. So usually the name of the first branch is master. Earlier I told you about master is basically different versions of same source code, right? So usually the name of the first branch is master, and that is by default. So we here we have told that we have to push master branch to the origin, and as you can see, it has sent everything to the remote repository. So if you'll just refresh this page, you'll be able to see that there is a file here, and that is called index.html, and that is the same things as your local repository, right? All right. So uh, yeah, uh, now if we want to make changes to the remote repository, uh, we can just, although this is not preferable, but I'm just showing you, if we want to make any changes to our remote repository, we can just start editing from here. And also it is highly not advisable to make changes to your code using Git, because there might be a bug that you know that wasn't caught by you, because this isn't an ID, this isn't something that is used to make changes to the code. So uh, I have made changes to the code only for the demonstration purposes. Now that we have made changes to our code, we have one more commit here, and it is update index.html. And just one second. Yep. Now what has happened is that our remote repository is ahead of the local repository. Now we want to bring changes from the remote repository to the local repository. How do we do that? So for that, we have a command git pull origin master. Origin is again the name of the remote repository, and branch is the name of the branch that will be pulling all the changes from. Opposite of each other, right? Push, pull. So when we execute this command, all the changes that were there in the remote repository, they'll be brought to the local machine, as you can see. So yeah, so let's try that. Git pull origin. Origin was the name of the repository. All right, let's see if the changes are reflected in this file as well, in the local machine as well. Yeah, so there was hello world here and below body, and now it is not there because we removed that from remote repository, and then we pull all the changes from the remote repository. Yeah, so this was how you interact with your yeah, just one second. This was how you interact with your remote repository from your local machine. These three commands. First, you connect your local machine to the remote repository. Then you use either git pull or git push for either pushing or pulling the changes. All right. Yeah. Now, earlier I said git is confusing, but up to this point, it doesn't seem like it is really confusing. I mean, with uh, with some practice, you can master it, but uh, this is where the actual confusion starts. Branches, branches in Gits, or different versions of same source code. So earlier I told you that the name of the initial branch is usually master, and this asterisk signifies that this is the branch that we are currently on. All right. So how to create a new branch? The command for that is git branch and branch name. That will create a new branch. So let us create a new branch here. Git branch, and let's say the name of the branch is Git basics. This is created in new branch, and yeah, so we have another branch here after this command is executed, and we might want to yeah, before that, actually, once we have more than one branches, more than one branch, when we'll make a commit, the commit will be only reflected in the branch that you are currently on. So we are still in the master branch. If we'll commit any changes, then it will only be reflected in the master branch. New branch will still be there, will still be in the previous state. All right. So what if we want to go to this branch and start making changes to this branch? So the command for that is git checkout branch name. Let us do that. Just one second. Yeah. Git checkout Git basics. So as you can see, it has switched to Git basics. Now if you will make any changes to this branch, first of all, as you can see, the asterisk sign has been moved to the new branch. And now if we'll make any commit to this branch, it will not be the commit will not be made here. Instead, your Git working tree, your Git, the tree that your Git has, it will be branched. So basically it's like having two histories. right? So one history is here on the master branch, and the another history is here. So if you'll make a commit, it will be branched. The Git tree will be branched, right? Now, suppose I'll just demonstrate you how Git branch works. Just one second. Yeah. First, we'll switch back to our master branch. Yeah. Now, sorry, what is this? Sorry. I'm sorry, guys. Yeah, we are on the master branch now. So we'll just make a few changes. Hello. We have added hello here. Now we'll just commit our changes. Index.html. All right. We have made changes to this file. Now if we'll switch to the another branch, yeah, if you'll switch to the another branch, you can see the hello has been removed from here, and that is because we didn't commit hello to the other branch. The hello is only committed in the master branch, right? So we can perhaps write a different version of the same code here. We can write hello world here. All right, and now if we'll make a commit, what will happen is just one second. Yeah, now we have made a commit. Now if we'll move back to the masters branch, we'll be able to see that the commit has not been reflected on the masters branch. Master branch still has hello in it. All right, so this is basically two different history of uh, yeah, basically two different histories has been created, two different versions of the same code. All right, now how do we merge those changes? So for that, we have command git merge and branch name. So branch name is the name of the branch that we want to be merged in the current branch. For example, if we are on master, we'll be merging new branch. So branch name will be new branch, or for us, git basics. So we are already on the masters branch. So we'll try to merge the git basics here. All right, and actually it didn't merge because we made change to the same file, so there was a conflict in the history. If the changes were made on two different files, then it would have merged simply. The changes of both of the branches would have been reflected in a single branch. And how merging looks like. So basically what happens is, yeah, so as soon as you click on merge, as soon as you enter the command merge, both of the both of the changes gets add, and they are reflected on a single uh, branch. For example, in this case it is reflected on master, but in our case we weren't able to merge it because the changes were made in the same file. We wrote hello world in the same file and hello in the same file, so that cannot be merged automatically. We'll have to resolve conflict, and for resolving conflict, I think that is out of the scope of this presentation. So we'll I think we'll just skip that part. Okay, just give me a few minutes. All right, yeah. Next we have git reset. So remember I told you about the undo thing that computers have, right? So uh, how do we exactly undo all the changes in Git? So for that we have Git reset and the reference. What is reference here? So if you'll sorry yeah so if you'll type the command git log, you know, all the commit will be shown to you. These are the commits that we have made. First we made a commit called random stuff. We are currently on the masters branch, so first we made a commit random stuff. Then we made a commit update index.html, and this commit was made on the remote repository, if you remember. And we finally made the commit add hello in the masters branch, right? And this was the latest commit, therefore it is the head of the this is the head of all the this is referred to as the head of the uh, branch, right? So we might want to, you know, revert the changes. We might want to reset all the changes that we did in the add hello part, and we might want to, you know, get back to the time frame when we just had made the update index.html thing, right? So for that we have this command, and what it does is it simply uh, deletes the latest commit, and it moves back to the reference point that you have given to Git, right? So it reverts all the changes and it moves back to the reference point that you have given to Git. So we'll just have a demonstration of that. All right, yeah. So we might want to move back to this commit. All right. Git reset, and we'll be moving back to this commit. All right. So this has moved back to to update index.html. That means we have undone everything that we did in add hello part. But if we'll open the file, we'll see that, yeah, if we'll open the file, we'll see that the hello text has not been removed. And why is that? Why uh, hello was added in add hello commit, and we have undone that thing, right? So it has to be removed, but it hasn't. So the reason is that we have moved back to this commit to update index.html, but all the changes that were there are also there in the file. Only thing is that those changes are currently in the working area. They haven't been added to the commit. They are still in the working area. So you can see here it's written unstaged changes after reset. This means that there are some changes in the in the index.html file that hasn't been committed, and those changes are uh, is this hello part, because that was not a part of the commit uh, update index.html, right? So what if we want to undo all the changes uh, that we made on add hello part? So for that we'll also add this command dash dash hard. So as you can see, it has undone everything. It has not only moved back to the uh, it has not only moved back to the previous commit, but also cleaned everything from the working area. All right. So for that we had to use git reset, the reference to which we had to revert to, and dash dash hard. Now if we'll, you know, open git log, we'll be able to see that there are only two commits. First is random stuff, and second is update index.html, and the third commit which was there has been deleted, and update index.html is the head of the master, right? So uh, actually there's a better way to you know, revert all your changes, and that is git revert. So how is Git Revert and Git Reset different? So what happens in Git Revert is that this commit is not deleted. Instead, what Git does is it undoes everything that has been done till since the previous commit, since the commit that has been made from the reference that you have given to the command. It undoes all the everything, and it creates a new commit. So basically the history is not erased, the history is not modified, and that is better because you know, being able to delete or change your history is a very powerful thing, and you have to be responsible while using commands like git reset. But git revert provides you a safe path for doing that. It simply undoes everything and adds that as the new commit. Okay, so let us have a look at this command. Git revert, and we'll revert this commit. Right. So as you can see, an editor has opened and it will ask me for entering a message. So uh, for making a commit, we have to give a message to the that has to be saved along with the commit. For example, we first uh, use the message random stuff and update index.html. So for this time also we'll have to add some message, so we'll just add reverting. Okay, and as soon as we close the editor, you can see that it has reverted everything. And if you'll open the this thing, you can see that hello world is back, which was there in the first commit. Yeah, so hello world is back. But if you look at the git log, you can see there is random stuff. Update index.html is still there, but there is a new commit, and that new commit has all the changes uh, has all the changes that are necessary for git to revert everything that was there in the update index.html. Okay, so that's how it works, revert. So what revert does is it creates a new commit. Okay, now I think this is the second last part of the presentation, contributing to open source, and this is a live demo. Okay, so I'll be demonstrating you how you can make contributions to the open source. It is Hacktoberfest, and by by learning to make by learning how to make contributions to the open source, you can win rewards from the digital ocean, or for this Hacktoberfest event, right? So I'll just quickly demonstrate you how you can make contributions to the open source. Yeah, so this is GitHub. As I told you before, what you have to do is you have to open any public repository. Remember I told you about the public repository. Those are basically the projects that are, you can access, anyone can access any repository. For example, if I search HTML, there'll be number of public repository that will be shown to you. Those are not your projects, but they are public, so you can see them. All right, so you can contribute to any public repository. uh, I have opened the Hacktogen organization, and I'll be showing you how you can make contributions to Hacktogen. But you can also use this to just make contributions to any repository, any public repository. So for example, let me open this project Halide. This is an operating system that is developed by KIIT. Two students from KIIT developed their own operating system, and I want to make some contributions to this project. So how will I do that? All right, so here we have a fork button. I hope you all can see me. Yeah, here we have a fork button. All right, So we have to click on the fork button and we have to fork that repository to our own uh, what do we call that, profile, our yeah, our own profile. So we have forked the repository, and as you can guess, this is basically a clone of everything that is there on the Hacktogen. But if you make any changes to this forked repository, it will not be reflected on the, you know, it will not be reflected on the Hacktogen, on the original project that is there. All right. So uh, we have forked the project. Now, actually, let's not do it this way. This is not a really good way to make contributions to any project. Yeah. So this is the forked repository. What you have to do is you simply have to click on this code button, copy this URL, and you have to one second actually. Yeah. So we'll open git bash here, and we'll just clone the entire project using git clone shift insert. We have pasted the link that we copied from the remote repository. It is getting cloned. Yeah. So before this, before moving ahead, let me just clarify on what is difference between Git Pull and Git Clone. So we used Git Pull to bring all the changes to our local repository, and now we are using Git Clone to clone the entire project to our local machine. So Git Clone is used when you do not have a copy of that. When you do not have the copy of that repository on your local machine already. Okay. So you'll be using git clone to just copy the entire project, and what pull will do is whenever you have a project, whenever you already have a project, already have a copy of that project on your local machine, git pull will simply pull all the changes that are there. It will not pull the entire project, it will pull only the changes that were made uh, on the remote repository. And uh, uh, yeah, so for git pull to work, remote local repository has to be there, has to be present from beforehand. And for git clone to work, uh, I mean, it can work in any scenario. It just have to download the entire project. That is the work of git clone. All right, so we'll just, yeah. So we have entered git project halide, and actually let's make any changes to this file. So for example, this is a file, and we'll just add a command comment here. Yeah. So random comment. I'm adding a comment here, but you can add anything. You can find a bug and maybe fix that bug. You can change the entire code. You can just do anything. So for demonstration purposes, I'm adding a simple comment. All right, we have added a comment, and now we'll just add, actually, yeah, project halide / src / we can do this, but there's actually a better way to do this. You can simply write git add dot, and what this dot does is it will, you know add the entire folder in the staging area. So it will tell Git that anything that has been changed should be added to the staging area. Alright, so this is used when you do not want when you want the entire project to be added to Git, because you do not want to go about writing Git add for every file that you have made changes to. So you just this is just a shorthand version of the command git add dot. Yeah. Alright, we have added all the changes. Now let's make a commit m random changes. Okay, now let's push this change to the so we haven't added the remote repository here, because when you're doing clone automatically adds the remote repository with the name origin. So the default name for while you're doing clone for the remote repository is origin. As you can see, we didn't execute the command git remote add origin and the link. We simply did git clone. Yeah. So git push origin master. So this command worked. This means that origin was added by default with the command clone. Alright. So if you'll refresh this page, you can see that the commit which I just made has been reflected here. Random changes. If you'll open the file, you can see that the change that I made is reflected here. Alright. Now that you've made the changes, it is time to create what is known as pull request. So after you made the change, you can see this branch is one commit ahead of Hacktogen master. Alright. So you have to create pull request button here. We have to click on the pull request button here. It checked for the mergeability of the project. If two or more developers were working on this and they made changes, they pushed their changes at the same time in the same file, then there might have been some conflict. Earlier you saw that there was some conflict in merging. So the same is true for creating a pull request. If you make changes to same file, if two or more developers make changes to same file, there'll be conflict. This time we don't have a conflict, so we'll just click on create pull request button here, and we'll create again pull request. Yeah. So the pull request has been created, and you have made your first contribution to the any public repository. All right. Yeah. So that was a live demo. Now we'll be moving ahead with the topic Google Summer of Code. Google Summer of Code is based entirely on Git, entirely on the concept of open source contribution. You have to be very well versed with everything that is there in Git. You have to be, you have to know how to, revert from any situation, how to how to work with a lot of different branches. You have to know how to work with difficult scenarios. That is Google Summer of Code, and we have Google Summer of Code winner 2020 Divyanshu Mahajan with us. He is GSoC 2020, and he'll be giving us a talk on GSoC. So he'll be here in a minute. I'll just we'll just wait for 1 minute. Till then, I think you can watch maybe this. Yeah, I think it is working. Yeah. All right. So, hello everyone. We have Divyanshu Mahajan with us, and he'll be giving a talk on GSoC 20, GSoC, which is Google Sum of Code. So, over to you, Divyanshu.
Hello,
Yeah, yeah,
am I
you are live
audible?
now.
All right.
Yeah,
So before I directly jump into Google Summer of Code, I would like to talk about open source in general. So getting involved in open source software development has a lot of benefits. It helps to improve your technical skills as well as soft skills. But before we get into this in more detail, some of you might ask, what is open source software? Any software that is free and accessible to everyone is basically an open source software. In such a software, the users don't have any limitations in regards to modifying the software or using the code into something else. Name a few of these open source softwares. You have Firefox, Chromium, VLC, Linux, and etc. Now that it's briefly clear what open source is, some of you would be thinking that why do we need open source? Why not continue with some proprietary software? Imagine a case where you want to learn Django, a backend web development framework, and if it isn't open source, in this hypothetical case, then you would have to buy a license or certification to learn it first. And maybe later on, you would have to buy another license to use it in your projects because not everyone has access to it. And that would be highly inefficient and disastrous, right? So that is something none of us would want. This is just one case, and there are multiple reasons as to why we need open source. Anyway, before we head on to why should you contribute to open source, need to know how it works. As Ayush said, in the world of open source, there's this project you want to contribute, and each project has maintainers who own and maintain the project. There could be one or more maintainers, and these are generally the members of the community under which the project was established. And then we have contributors who are people like us and volunteer to contribute in making the software better. Now, you as a contributor make patches to their software and submit that to maintainer in the form of pull requests. Those are then reviewed by those maintainers and then get merged into the code base if your contributions are valid. So by valid, I want to say that it passes all the checks. It aligns with the coding style of the organization. So that is how it generally works. Now the question arises, why should you contribute to open source software? And what benefit will you get out of it? The first point is that it gives similar experience to real world software development. This is important, especially for undergrads like us who haven't worked in the industry before. The second point is that it gives you a chance to apply your skills into something that others use. More importantly, the exposure that you get will help you improve your technical skills as well as soft skills, as I said earlier. And last, the satisfaction that you get from seeing others using the software that you contributed to is far greater than anything. To give you an example, my project was Gamepad Navigator, and it was amazing to see people using the code that I wrote to help them with browser navigation. So that's what open source software is and what you get out of it. Now, to start off with open source software development, there are a few prerequisites. You need to know a few things beforehand. The first one is Git. Git is a version control system that Ayush talked about in the beginning of this session. And second is a medium knowledge of a programming language and a tech stack. It can be anything, be it app development, web development, machine learning, and so on. So there are these programs that were started to promote the open source culture, such as Google Summer of Code, Outreachy, Code Heat, and Hacktoberfest, which is currently going on. So now we move on to Google Summer of Code. Google Summer of Code, commonly called as GSoC, is a global program by Google. It focuses on bringing college and university student developers into open source software development. The program is about 16 weeks, and during the summer, when you will work on an open source project, under the mentorship of a few people from the organization. So that's some definition and technical terms we put for your clarity. But there are some things you should know and realize beforehand. First is that it's not an internship by Google or the organization you have applied for. It's just a summer program for promoting open source. That's all. Nothing more, nothing less. Second, and the most important, it's not some sort of trend that you need to follow. If you realize the importance of open source and are genuinely interested in working on the project you are applying to, then only you should continue. What people do is they pick up some project according to their comfort and then they don't even care to look at it after the program ends. This is really bad and you shouldn't be doing this, especially when you commit to be part of the project and the community. Now, the question arises, how does the program work? First of all, the organizations apply for Google Summer of Code by the end of January, and then the participating organizations are announced by Google by the end of February. Then students like you all look into the project ideas from various organizations and apply for the projects they are interested in by submitting a proposal. The student application period usually remains by the end of March, and the selected students are announced in early May. Therefore, those selected students start working on the project with their mentors after the results are announced, and the students do have evaluations after they get selected, and these are done on the basis whether they are able to cope up with the proposed timelines in the proposal. If they successfully pass all the evaluations, then only they happen to complete the program and get all the incentives that the program has offered. Now that you have clarity on what the program is and how it works, let us move on how to get started with GSoC. The process usually remains the same every year and is divided into three major steps. Okay. So the first step is finding an organization. Generally, when students start off somewhere in January or maybe a bit early, somewhere around by the end of December, the participating organizations are were not announced, or so what they do is they refer to the previous year organizations, and then a question comes into the mind of these applicants, and that I have been asked many times is how to select an organization. First thing you should do is go to the organizations list on the GSoC website. Let me just share my screen with you so that you get the idea. Mm, Can you see my screen? Can you see my screen? Can anyone confirm? No? So this is the organizations page, and there are two ways to filter down the organization. First one is the top. Hmm? Mm, okay. Let me try again. Uh, can you see it now? So this is the organizations page that and those are 2020 organizations that participate this year. So there are two ways to filter an organization. The first one is the top-down approach, where people learn some skills and then filter the organization on that basis. So for example, you picked up Node.js and you now want to work on a project that uses Node.js. You have the website, you click Node.js. Uh, Apologies, my internet is quite slow. So here you organizations that use Node.js in their tech stack. So if you want to look into all the organizations, you can from here. And if you want to specifically look at 2020 organizations, you can use. Apologies for that. Actually, my internet is quite slow. So can somebody tell where I last left off? Okay, so Ayush, can you share your screen? Like, can you open the website? Um, it's summer of code dot with google.com. Yeah. Yeah. So can you search for Node.js? Like we were continuing with that example. Okay, so what I was saying that you can open up any of these organizations page and Ayush, can you open any of them? I guess that's the wrong page. You have to go to the organization page. So uh, just click any of them. Okay. So here you can see that there's once you have filtered the organization based on your tech stack, you can see that they have this ideas list button. So clicking on that will lead you to another page where you can see the proposed ideas, and you can get all the details related to that from there. Ayush, can you open the ideas list? All right. So here it will contain all the information for the projects and what the student is expected to do, and uh, who's the possible mentor for the project, and what tech stack is needed for that specific project. So if you scroll down, you will find the list of projects. So yeah, so this one ready ideas. The Irish common first. Okay, so this one is usability improvements. Irish, that's fine. You can stop this. So yeah, so the one project is hello, I'm audible. Okay. So the one of the projects is next generation WPS. Uh, so here they have mentioned what they need. They want a all.js extended with WPS client, and you can read that line. So they have mentioned what they need to do and what's the project about in the explanation section, and the possible mentors for the project. So I would say that invest as much time as possible on this section, because it will help you to understand what the idea is and which project you should work on. So once you get an idea of what it is, you can go to their community channel. It is the link to the community channel will be mentioned on the GSoC page of the organization. From there, you can navigate to that page, and that's one way you can filter the organization and the project you want to do. And another way to filter an organization is the bottom up approach, where you will filter an organization based on the domain they are working in. So let's say you are generally a student who's more interested in making compilers or maybe something related to that. So you can filter out the organization based on that, and you can see their ideas, the projects they have mentioned. And if you like one project, you can simply choose that and start learning the tech stack they have used in it. So that's another approach. And what I would say is you should go with the top down approach, because it's easy to understand the project initially, and as you are generally aware of the tech stack, and you can jump into contributing relatively earlier as compared to the bottom up approach. And another question that arises is, how many projects should I look for? So GSoC allows you to apply for maximum 3 projects, be it under the same organization or different one. But do keep in mind that you will be working on one project only if you get selected. So also make sure that you pay great attention to this page, because it, as I said earlier, it contains all the information you need. And what people do is it they find it quite overwhelming to go through the whole page. So they directly jump into the communication channel, and they uh, simultaneously bother the mentor about what the project is, what they need, etc., which is already mentioned in this page. So that creates a wrong impression for you, and you shouldn't do that. You should rather put some time here. Maybe you start late, but it's worth it. Okay. So once you are done with selecting the project and the organization you want to work with, join their communication channel or the mailing list according to what they use. Then introduce yourself to the community, describing your interest in the project and mentioning you want to contribute to it. So here I want to drop a few tips for you so that you don't end up embarrassing yourself later. Just keep your introduction simple and don't over exaggerate your skills, such as mentioning everything you have done till date. Just mention the ones relevant to the project and describing your interest in the project and why you like to contribute. and they care less about these things such as you continuously showing off or something like that. All that matters is the way is the contribution you do and the way you interact with them. And when I say the manner you interact with them matters, it does matter a lot. People simply get rejected because they fail to understand the feedback received from other members or mentors, or couldn't maintain the communication at all. Also, please don't bother your mentors too much simply because you want to get noticed. It will irritate them and create a bad impression of yours. Respect their time and they will get back to you if and when they can. So once you reach at this point, you should now start looking for issues on the project repository and try to find the very easiest one that you can solve. So the first contribution will always be the hardest, no matter how easy it actually is. But and you will see other people making more contributions than you in a shorter time. So don't get demotivated with that. It's completely fine. To give you an example, my first contribution was changing the color of a button and removing the extra white spaces from the documentation. That's it. Nothing big as such. And I would say that you will gradually pick up harder issues as you move on and contribute to their organization. But start off with something easy that you can do. So there's more things to GSoC later as you come close to the application and your proposal period. But keeping in mind the scope of this session, I think what I shared should be enough to get you started with open source contributions. Again, I want to thank Developer Student Club for having me here. It's really great to see you all participating in open source, and I hope you found some value in the session. Thank you.
Yeah. Uh, Thank you, Divyanshu, for you know coming to this meet and sharing and giving an insight on what open source is and how you can contribute to GSoC. Thanks a lot for that. That was really helpful. Now, I think we are yeah. Now I think we are open to questions. So anyone, if you have any question either regarding the open source or the GSoC, you can ask them now. Questions related to other things that is related to the Developer Student Club, we'll handle that later. So for now, just questions that are relevant to open source or GSoC.
Hello, am I audible?
Yeah, you're audible.
Yeah, so I have one question that for a complete beginner developer who is interested in like developing, what should be the considering the time left for the organizations to get announced and the timeline for the application? So, what should be the best strategy and what should a beginner developer start learning if we want to target GSOC 2021?
Okay, I think Divyanshu Bhaiya can answer that. Yeah.
So yeah. So actually, you shouldn't look for anything specific just to cover GSoC, or as you said, you want to target GSoC. It's just that you keep on learning, and if you are interested in that tech stack and you start to like that, you will you would have enough time to look for an organization. Right now it's October, and I would say that you have more than enough time because people usually start in January or February, and I have seen them getting selected. So if you want to explore something, like if you want to learn some tech stack or maybe some language, then you should start now. Maybe try a few things, like try web development first. If you don't like that, move on to app or maybe something else. But I would say that you would have enough time to cover and explore other areas. So it's not like that you would not have enough time to learn something and then apply for GSoC. Personally, I started myself in January, so you can say that there's enough time for you.
Thank you. I got your point.
Okay, anyone next question?
Hello.
Yeah, hello.
Sorry, can I just ask if GSoC clashes with PS1? Like, is there a difficulty or problem with doing both at the same time?
Actually, our PS1 was shorter compared to the usual PS1, so I didn't have problems. But usually, I have heard from my seniors as well. They have also completed their GSoC with PS, and they had no big problems at such.
Okay, thank you.
Okay, any more questions? I think there are no more questions, so we can move on to the end of this session. It was a great demonstrating everything to you guys, and we'll be stopping the meet here. We'll be ending our meet here. So if you have any questions related to DSC or any other thing, you can join our Slack workspace, that is Developer Student Club workspace, and you can